name is Mindo. I do motor vehicle repairs and amongst the Safari Rally, for those who see those Safari Rally cars and everything. I'm here with Ruth. She's a motor vehicle engineer. We work with her on cars and rally cars. I remember I've seen some of you who came for rally last time. Yes, so at least I have seen some of you, and we have interacted with the buggies and everything. So today we want to start on this car that was manufactured in 1977. How many of your parents were born? Parents, not you. And it has not been used since 2006. How many of you are born in 2006? Good. So it has been sleeping since then. So we want to, first of all, restart the engine. So what it will help us do is also learn the basics of mechanics or basics of an engine. Why? Because these were what we call basic engines. They were as standard as they could be. So last time when we were at the buggy, there's somebody who asked me what is a 4-stroke engine. Okay, do you know what is a 4-stroke engine? Yeah, you do. Yeah, an engine that does what?
Those
4 cycles.
Yeah.
Which are induction.
It was compression.
Power.
And exhaust.
Very good. So this is the typical 4-stroke engine. So the first thing we did when we got here was to turn the engine by hand because it has been sitting for so long and it was stuck. So we removed the spark plugs, put oil inside the cylinders and turned by hand. Because if we didn't do this, then it would not turn at all. We made sure the engine can turn by hand. So it's now turning and going round. Then, interestingly, because we don't have a key, we looked for how to start the car without the key. So we got the 2 wires for the starter and put power, and the starter is able to turn it. Okay, now you need to move from that side because it's going to splash oil. Come to this side, it's going to splash oil out. So the 2 wires on this particular car is this wire from the battery and this wire from the starter. So if I hold there and I hold there, so fast it turns. So when you're starting a car, that is what you do. That's what the key does. When you do this, so that's what it does. Okay? So now because we know the 4 cycles, so the first cycle will happen because the engine will turn, induction. So the second cycle, which is compression, will still happen because it will mechanically go up. That cycle, which is power, we need to get power inside. So for power, we get from the spark plug. So we must get power here, and the spark comes here. So we will now use an old system of getting, the original system of getting spark plugs, using a conductor and a coil. So that's such that when it moves around, it opens and closes. So when it opens, when it closes, there's power, and which goes to a coil, and a spark comes out. Are we together until there?
Yes.
Higher. So look at this turning when we crank. I will explain later because we'll cover it. You see? Sawa? So then you can see the way it's splashing out. That is now when it's trying to compress. But because there are no spark plugs, it's not throwing out. Already petrol that is throwing out. So it's waiting now for spark plugs to compress, to be able to compress. So let us go to how do you create a spark. By hand slowly, so that you can see how it goes. So this shaft here has 4 lobes. You can see them. 1, 2, 3, 4.
Yes.
You can see? 1, 2, 3, 4. There are 4 lobes, representing the 4 cylinders. So every cylinder is allocated 1 lobe. So such that when you turn, when this cylinder is up, the respective lobe will be opening and closing this. As in, see how it's going? So when it, like someone like there now it has opened, it will open the gap here. There's a small gap here. So it will open that gap, which means it disconnects power. The minute it goes off the lobe, there, then this, the 2 points close, power comes in through this wire to this coil. The minute power comes like this onto the coil, because this is a coil with oil and many coils inside, a high powered spark comes out from here, from this wire.
Yeah.
A lot of voltage. Yeah, actually 12,000 volts direct current. Such that if you touch it, you'll actually feel the impact. It can't kill you like the power. Yeah, because if you remember, have you done the oscilloscope graph?
Not yet.
Not yet.
Yeah.
So direct power goes only one direction, but alternating current, which is now like this Kenya Power, goes up and down on a graph. So then it goes up and down. When it goes down, it will ground you to the ground. But this one is only direct, so it is on the upper half. So it will hit you. You will feel
The vibration.
not vibration, a good shock, a very heavy shock. It cannot kill you, but it will give you a good shock. So that is the power that goes to the spark plug.
Yeah.
Yes. So let's say that again. When the circuit is closed, at that particular moment, power comes to the coil. It produces a high voltage spark that goes to the spark plug and ignites the engine.
Nice.
Yes, that is how it works. Yes. Repeat that to them.
So he said once it closes, a high voltage of power comes this side, then it's released here onto the spark plugs, and the spark plugs ignites the engine.
Is that correct?
Yes.
Yes.
That is very correct. So we'll try and do it practically to see whether we can get a spark coming out. Like first cleaning, yeah, making sure. See now, between these two, there's no contact because it's dirty.
Yeah.
Yeah, so we'll just clean it with the flask, whatever. The air fuel ratio in an engine, because it needs to get power. Any question up there?
You put some oil
Yes.
into there.
Yes.
Was there a reason you did that?
Yes, because the pistons were stuck.
Okay.
It couldn't turn.
Okay.
So I put oil inside. So I let the oil seep in. Then I turned by hand and lubricated it.
If you try to start without putting oil, what would
Then
happen?
it would break the rings. The piston rings would break. Even
You guys know about piston rings?
Yeah.
Yeah?
Yes.
Yeah.
Or in fact, anything that was inside there that was stuck metal to metal would actually now break. So that's why you first pry it so that it becomes smooth.
So maybe a question.
Yes.
What happens then when the spark plugs are worn out?
So when the sparks are worn out, the engine might not start or might malfunction, not have enough power to run the car.
So maybe you explain to them something about that power.
Yes.
How does it affect the speed as well as the performance of the vehicle?
So on the third cycle, which is compression, not compression, power. Power. So when it sparks, then you have power.
Yeah.
The intensity of the spark and how it happens is what determines how much power you have. Yes. So it's important to have a good spark. So anything. Sorry, ask.
So the more intense the spark is, the higher the power.
Higher the power. Yes. So the more intense, the higher the power. So that ask.
The different cars produce different amounts of volts.
Yes. Yes. So the cars, this particular, what we are seeing here is from this particular model, which was built those many years ago.
Yeah.
So all these mechanical things, all these things of turning and everything, in modern cars have been made electronic. So this power comes from a transistor. When you look at the figure of a transistor, it has a ground and what else? It normally has 3 poles. So when it removes power, it is that power that comes there. So on the modern car using a transistor or the electronic ignition, you have a better spark. So you have better fuel consumption, you have better power on a newer car than this. Yes. Ask.
So does it mean if the higher the voltage, the better the performance?
Yes, up to a certain level. It also has an optimum level. So on the newer car, you'll find that spark looks even more mean than this. Yes.
Okay, like let's say I'm new to about spark plugs,
Yes.
and I want to get one that is suitable for my car, because the one that was there is already worn out. How am I able to identify which one is?
Every manufacturer has the type of spark plugs they built the car for. With. So they'll tell you, like for example, this one is written some numbers. So this Mercedes, the number will be this, whatever number is here, WDC. So this Mercedes manufacturer made it to work with a WDC spark plug.
Oh yeah.
So a Toyota same has its own spark plug. Even a lawnmower operates on the same principle. Yes, and a lawnmower also has its own spark plug.
Okay.
Yes.
So maybe a difference between a generic spark plug, a frequency, and the generic.
Oh no, that gets a bit technical because it depends on who's making them. Yes. So let's just assume all of them are genuine. Yeah. All of them are genuine. Yes. Because the fake ones, the fake ones are fake. But like these cars do not have fake things, then we see as well not fake things. Yeah. So what is this number written here? 1342. That's the yes. No. No.
The number of the manufactured engine.
No. Think about it from the power aspect. We say we have
How much power it?
no. Think about it from the 4 cycle. No.
How much
Remember,
combustion it produces?
the 4 cycle, what do you call it? The
Four-stroke.
4-stroke. Remember, on 4-stroke, you have the 4 cycles. So you need the cylinders to fire at certain times.
Also, like you're saying, one side starts at a specific time. Not at the same time.
Kind now you're almost getting there. Yes.
The order in which the
Fire. Exactly. That's a firing sequence. Correct.
So 1, 3, 4.
1, 3, 4, 2. So and cylinder number 1 being close at the front. So to fire first cylinder, then fire number 3, then fire number 4, then fire number 2, then fire number 1.
So it continues as a cycle.
The cycle like that.
Okay.
Yes. And that cycle is determined by the arrangement of the wires here. It's the arrangement of the wires here. So remember this thing is turning around and bridging and giving the power.
Yeah.
So how they are arranged out of the cup is what determines firing order. But why they wrote it there is so that you know that is the firing order. Yes.
So like, is there a specific reason maybe why they go from number 1 to 3?
Very good question, and yes, there is. So remember how the crankshaft is curved.
Yeah.
So you want number 1, when number 1 has fired, the next one to come up will be number 2, but to be an exhaust. So number 3 will be coming up on compression. Then so you fire it. Yeah?
Yes.
Then after number 3 you fired it, because of the shape again, number 4 will come next on compression. Then you fire it. Then the remaining one is number 2, so it will come up on compression, you fire it. Then you repeat.
Continues as a cycle.
Yeah, it continues a cycle. Again, also it also ensures that the engine is balanced. So because you fire here, you fire here, you fire here, then you fire here, you fire here, so there's balance. Yes. All 90% of four-cylinder engines fire on the same sequence. But now remember, the other cars that are 6-cylinder, so they have a different firing system. The other cars that are 8-cylinder, they have a different firing system because they're 8 cylinders. Yes. So the most basic 1, 3, 4, 2. In fact, 90% of cars, that's how they fire. So I'll ask Ruth to come and assist now in putting the spark plugs. The bridge from the center to individual lines. Okay, after that we're okay?
Yes.
So, yeah, and just go in one way. That way, it's right in. Okay, then put a cover Just to put.
7 to 7.
Yes, the team. This so we have predetermined that this is number one. We know that from knowledge that this is number one. So we put this in number one. Then one. Then the next one is three. So this, the next one to that number one, which is this one, goes to number 3. So which one is it? This one. That one. Then the next one, 4. So from this one is this one. So this one goes to number 4. Then this one, number 2. The remaining one, number 2.
You also have to place them in order.
Yes, it must be in order.
If they're not to
Then it will not start. Yes, it will not start. Now, this is where we now have to be careful because there might be a pop back. Boof, 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 boof. Because we are starting the car now. Now there's spark going to the engine, there's fuel going to the engine. So now it can, yes. So Bilal, let me come and do that.
Remove your heart.
Move your hands.
Remove everybody. Remove your heart.
So there's power, there's everything. So now it is the actual start. So now we have power there, and we have power to the car. Okay? Again. Eh.
could be exhaust.
Coming from the piston.
Yeah. Sasa, haya, again.
It's moving smooth.
Again. Again.
Magic.
The magic of mechanics.
Yes, it's starting! It's started! Yes, it's started!
Now you have our car running.
We need to have fuel.
Yes.
I have a question.
Yes.
What's wrong with this thing?
No, it's because we don't have enough fuel running through the system. That's why it's popping back.
Wait, it's
So
supposed to cause a flame.
The flame is supposed to be on the inside, but because there's less fuel here, that's why the flame is coming back. Yes. With that number, okay, that number denotes the width of the tire in millimeters. Width from here to here. So this will be a 285. This will be a 165. 165. That will be a 195. 195. And that one? 285. That's the size of the tire, the width of the tire in millimeters. Okay?
In short, it's how fast the tire is.
How far the tire is.
Yeah.
So the next number on all these tires apart from this one is that stroke. Is the next number? Stroke 50. Stroke 50. Stroke 50. Stroke 50. And this one? This one is an R. That number stroke, is it an R? This one is an R. That one is a... No. Is that a stroke something? 50. 50.
Even that one should have a stroke, yeah?
This has got a...
Does yours have a stroke something?
Stroke? 65.
Yeah.
No, this is the R. That's the stroke. 50. That is the height of the tire. here, percentage of the width. Okay? Height of the tire from here to here, from here to here is 50% of the width of the fatness of the tire. How do you get that?
So it's like half the tire, half the.
So
width.
yes.
Half
So this on the arm, which is a real tire, is 80% of the width. Yes. It's rigid tire on construction. Rigid tire, yes. Yes, on construction, when the way the tires are made. So there are two types of tires. There's radial tires and translac tires. The good thing, I'll show you translac tires here. There's on the lorry. So radial tires are made with all the materials being made round. So the rubbers are coiled round. The metal that holds it for the rubber is coiled round. Those are radial tires. So these tires are all arc tires because they are radial tires. Okay? Then the last number is the size of the ring. 13. That is 13, 20 inch, 13 inch. That one? That's 20 inch. That one? 20 inch. That one?
15.
Sure?
Yeah.
15 inch. Yes. That's the size of the rim. So?
Is this 30?
No. Can imagine that is the size of the rim. Higher. Let's go to the next one. Tires have age. Listen very carefully. Tires have age. When was it manufactured?
Age.
If you continue on that tire, there's a place that has some number. X1218, like this one. X1218. So the first two are the week. 12th week of 2018.
Oh, these are old.
Wait, what?
Higher.
20 week or 27.
Yes. And that one? 38th week. Remember, a year has 52 weeks. Senior. So 38th week of 2017. And this one? Just say this is the other side. So you know Molim said that we have contraband things. Yeah, these are contraband tire. What? That's how it is. That's how it is. Yes, there's a contraband tire. A big tire.
Big tire.
So remember. Yeah, sorry. Yes, so 11th week of 2018. So remember, tires have a shelf life or its life. Useful life is 5 years. So a tire that is more than 5 years from the date of manufacture is an expired tire. It should not be used. More than 5 years.
Maybe these new ones are.
So you have to exchange the tire after every 5 years.
Every 5 years you must change tire.
Actually, these tires, I had one, just thrown it away. I don't know that you saw a tire here that had shredded. Yeah, you saw it. You saw that tire that had shredded. But so I was driving and it just shredded by itself. Because it was part of this.
It's an expired tire.
Lasted more than
5 years. Yes, they are expired tires.
Even if you feel the walls,
Yes.
the walls are very weak.
Very weak, yes. Yes, skip. Yes. Different manufacturers, it's not a standard thing. So different manufacturers label them differently. So you have to go reading and see. It's not a standard. You see all the markings are standard. Yeah, it's not a standard thing. So it's somewhere here. Should be somewhere here. One of these numbers. The speed. Speed can do the top speed you can do. Yeah. So I'd have to find out what Dunlop labels it as. It's not a standard thing. It's for manufacturer to manufacturer. But what is standard is the date and the size. Yes.
This one is really tubeless. Yeah. People don't use tube types. Even these are all tubeless. The only ones which are tube type are these ones. These are, long ago we used to use that. Yeah, long ago that's what we used to use. Yeah. But nowadays, it doesn't make sense. Do you know what the advantage of a tubeless tire is? So long as the nail stays inside, it won't leak. So you can drive for many miles with a puncture so long as the nail stays there. But once the nail comes out, all the air comes out.
So today we have accomplished how to start a vehicle that has been parked for a long time. What to do to ensure that the pistons and the crankshaft is not seized. Remove the spark plugs, put oil and turn it by hand until it becomes smooth. Then most importantly, we have learned the four-stroke system practically, and how to generate a spark into the spark plugs to start an engine. So all this, what we've done today is exactly what happens in a modern car and every car that uses petrol. Only that the systems are slightly different. Instead of carburetor, you have fuel injection. Instead of distributor, you have electronic spark plugs. Instead of having one coil with a distributor, we have one coil for every cylinder. So it becomes more effective. But the principle of every car running is this. This is all cars run on this principle. Okay? Very good. So next lesson, we are going now to repair the radiator, put a good pipe so that we're able to run the car for long with water and run the engine. And the accelerator, make the accelerator from the inside. And also the ignition. We need to get the key so that we're able to start the car from inside there. But again, the principle of starting a car is power to ignition and power to the starter. That is all the key that the key does.
Thank you for coming to teach us how to start an engine that is just and how it operates. And yes, we hope to learn more from you as the weeks go by. Thank you very much.
You're most welcome.